Hi, welcome to the video on arc length and sector area. This is the second portion. We've just finished talking about arc length, or excuse me, sector area in the previous video. So we'll finish off with the second video talking about arc length. Now, as you see here, we have a formula that's very similar to the one that was in our sector area. In fact, it should be very similar in that it is the same one. The only thing that I did now is instead of using area in my denominator in the first ratio, I'm using circumference. Generally, we are going to be solving for arc length, so this is what is still going to be our variable here, our x or y or whatever variable we choose, and then we'll be cross multiplying the same type of thing here. Over here on the right side, we are still dealing with our degrees, but instead of having the degrees of our sector, we're working with the degrees of our arc, and you'll see what's the difference in our picture. And then the total degrees of a circle is still 360. Now, to remind you of your circumference, I don't know if you remember, but it's 2 pi r, or 2 times the diameter. Generally it's whatever you're given, and if you're given the diameter, I would use diameter times pi, but if you're given only the radius, you would use 2 times the radius times pi, or 2r, or 2 pi r. All right, so let's get started with an example. So you see what I mean? This is the arc length. It's just the length of the circle that goes around, right? It's not anything that deals with the area here. It's just this length of the circle. All right, so let's set up the problem then. Since we are finding the arc length here, this is what our x will be. Our circumference is 2 pi r, and that's equal to the degrees in the arc, and this is given to us as 120 degrees, and we set that up over our ratio of the total degrees as 360. Just like in any proportion, we cross multiply to solve. We have 360x, and that's equal to these two values multiplied. 2 times 8 is 16, so I'm going to have 16 times 120 pi. Generally, I put the pi at the end. That's just a preference. You could write 16 pi times 120. Again, this is any of these multiplication rules that you can certainly do it in any order, especially if it's on the same side of the equal sign. All right, so I'm going to use my calculator, multiply these out. When I do, I get 16 times 120. I get 1,920. So I'm going to have 360x, which is equal to 1,920 pi. I'm going to solve for my variable x. That means I'm going to divide by my coefficient, my 360. Notice the pi is still here. I'm going to have my answer in terms of pi. So 1920 divided by 360 using my calculator is 5 1/3. And now I can write it as 5 1/3, like this. It's a little sloppy doing it this way. We can certainly write it as 5.3 repeating pi. That's a little better, but it still has that. We can certainly write that as an improper fraction. So we also can write it as, let's see, that'd be 5 times 3 plus 1. That's 16 pi over 3. And that's probably another way that we would see it. We probably would see it on if we were going to have a district assessment question on that, you'd probably see it like this. You may see it like this or like this, but again, you can always check it using this number times pi and check any answer. So 5/3 times the pi symbol. Again, the pi symbol is located at second caret, with the caret button is above the division symbol. And any of those answers still come out to the decimal. Let's say we're going to round it to the thousandths place, 16.755. So what does that mean? 16.755 is the length. When a circle has a radius of 8, the length of the portion of circumference is this, 16.755, and whatever units that you're using. So let's try another one. Here's our example here. Now, in this one, it doesn't really tell us the angle on this portion, but it does tell us this angle on this portion of the whole entire circle. That is a symbol for 90 degrees. So we're going to take the whole entire circle, which is 360, and subtract it with 90 to find out our angle. So 360 minus 90 is 270. So 270 degrees is what our angle is here. Okay. So we had to kind of like do a little housekeeping before we start. All right, so as you see here, our proportion is the arc length divided by our circumference. So the arc length is what in this problem that we're solving for. So there's my variable. My circumference is 2 pi r. R in this problem is 7. And that's equal to the degrees in the arc. And we located or we calculated that earlier as 270 degrees, and that's over the total degrees of a circle. So we have 360. Cross multiply, we have 360x, and that's equal to, well, 2 times 7 is 14, so we have 14 times 270 pi. We divide by 360 our coefficient. Oh, we didn't do that multiplication out. So granted, your calculator may do all of this all at the same time. So we can do 14 times 270, get an answer in our calculator. Then divide that with 360 all in one step. That'll save us some time. So 14 times 270 gets us 3780, and when we divide that with 360, we get 10 and a half. Don't forget the little pi is still there. That means our arc length is this 10.5 pi. And if we needed to get an answer as a decimal, we just simply multiply that answer times the pi symbol, and we round. I'm going to round again to my thousandths place, 32.987. Now this was a 6 and the number after that was a 7, so you do round up. The last type of problem are ones, again, where you don't even need a picture, and they give you the answer for the arc length. They tell you the radius, or they may even tell you the degree, and they want you to solve and for the radius or vice versa. And you solve. So I think there's a typo here. Whoops. So there's what we're going to do. So we have 64 pi, and that's our answer, and that's over 2 pi r, and that's equal to our degrees of our arc, which is what we don't know, so we're going to solve for that. And the total degrees in a circle is always 360. I cross multiply here. Again, I usually do my x first, so 2 times 4 is 8 pi times my variable, and that's equal to 64 pi times 360. So again, it's 64 times 360, because I generally put my pi at the end. All right, so I'm going to do 64 in my calculator. 64 times 360. And I get this large number of 23,040. And there's the pi that's at the end of that. And that's with 8 pi x. And that's equal there. I'm going to divide both sides by 8 pi. 8 pi. The pi's are going to cancel. We get this huge number divided by 8, so it's going to go several times around. We get an x equals 2,880. So that as you, again, it's one of those problems where you would go around and around and around, because remember 360 is what one circle is, so it would go around and around and around, and we get an answer of a very large number for the degrees. So that does conclude our video on arc length. I hope it helps.